Welcome again, students, to Physics Department. For Lecture 4.1, we will talk about work, energy, and power. So let's start with work. As you can see, work is a scalar quantity, not vector, or is it equal to the product of the force and displacement. So W is equal to force multiplied by displacement, or force multiplied by distance multiplied by cos theta, where W is work, which has a unit of joule, D is for displacement, F is for force, which has a unit of Newton. To be able to produce work according to the formula, we need force, which is a number 1. Second, the displacement. Third is the components along the displacement. Let's move on. Let's now define resultant work. Resultant work is the total work. After you compute the individual work of its forces, you sum it up. Also, it is equal to the resultant force. So, resultant work is equal to the resultant. So, let us now solve for number 1. What work is done by a 60 Newton force in pulling a cart in a distance of 50 meters when the force is transmitted by the handle and makes a 30 degrees with the horizontal? So how are we going to solve that? So we have here our solution. So first we will write our given. That will be force is equal to 60 Newton. Our displacement will be 50 meters. Our angle is 30 degrees. So we are looking for the force. We will use the formula W is equal to the force multiplied by displacement multiplied by cos theta. Let's do substitution. Our force is 60 Newton multiplied by 50 meters, which is the displacement, multiplied by cos 30 degrees. Entering that on our calculator, you will get 2598.08 joule. That will be our final answer if we're looking for the work. Our problem number 2. So, a push of 80 Newton moves a 5 kilogram cart up at 30 degrees inclined plane. The coefficient of kinetic friction is 0.25 and the length of the plane is 20 meters. So, how are we going to solve that? On problem number 2, this will be our FBD. So, as you consider is the push cart. Inclination degree is 30 degrees. We know that weight is equal to mass multiplied by gravity. And there. Next. For question number 2, we will first write our given. Our force is 80 Newton. Our mass is 5 kilogram. Our theta will be 30 degrees. Our kinetic coefficient is 0.25. So for solution, we are looking here for the network. In order to solve for network, we have to add all the work in all directions, which is the N, P, Fk, that's Fk, and W. So the work, we will solve them individually. Work sub N is 0 joules. Siya yung pataas. Next is the W sub P, which has a formula, force multiplied by distance. I forget to write the distance on the given, which is 20 meters. So that will be 1,600 joule. We already solved for the 2. We are still looking for the other 2. So for W sub F, that will be F sub K multiplied by the distance. So in order to solve for the F sub K, we have the formula kinetic coefficient multiplied by N. But in order to solve for N, we will use N is equal to weight Y sub Y. That's sub Y. Our formula for weight sub Y is work multiplied by, that will be sine 240. I'll correct that later. So, kung nagtataka kayo saan nanggaling yung 240, that will be 90 plus 90 plus 60. So, that's why it's 240. I'll change that cos into sine. But we also need to solve for the W. So W is equal to weight is equal to mass multiplied by gravity. Our mass is 5 kg multiplied by 9.8 meter per second squared. So that will be 49 in Newton. So you can solve the other solutions. So 49 Newton multiplied by sine 240 degrees is negative 42.4 Newton. And we'll go back to the first formula. 0.25 multiplied by 0.25 is given, multiplied by negative 42.4 Newton. So our F sub K will be negative 10.6 Newton. So let us now solve for W sub F. That will be negative 10.6 Newton multiplied by a distance which is 20 meter. So our W sub F will be negative 212 Newton. So we already have 3. We're on the last one. Last one is W sub W. That will be weight sub X, that's the vertical weight, horizontal weight, multiplied by distance. So weight X is equal to 49 Newton multiplied by cos 240 degrees. And that would be negative 24.5 Newton. So that will be negative 24.5 Newton multiplied by 20 meter. That will be negative 490 joules. So we already have our 4. W sub N is 0 joules. W sub P is 1,600 joules. Our WF is negative 212. I'll change that later, I'm sorry. And our W sub W is negative 490 joules. So that will be 898 joules. That will be our final answer for problem number 2. Next problem. In the figure, a block of ice slid down a frictionless ramp at an angle of 50 degrees, while an ice worker pulls on the block by a rope with a force that has a magnitude of 50 Newton and it's directed up the ramp. As the block slides through the distance of 0.50 meter along the ramp, its kinetic energy increases by 80 joules. How much greater would kinetic energy have been if the rope had not been attached to the block? So, if hindi daw na-attach yung rope sa block, they are asking how much more kinetic energy. So, we're gonna solve for the kinetic energy here. Let us now solve the problem by first listing our given. Theta is equal to 50 degrees. Our displacement is equal to 0.05 meter. Our kinetic energy is equal to 80 joules. I forgot to write the force, which is equal to 50 Newton, but I will correct that later. I've drawn FBD there. That's 50 degrees, and it's a right triangle, so that will be 90 degrees. And the other angle would be 40 degrees. Let's go now with the solution. To be able to solve for the other kinetic energies, we need to first solve for the work. That would be F multiplied by D multiplied by cos theta. Substitution. That would be 50 Newton multiplied by 0.5 meter multiplied by cos 180 degrees. 50 plus 40 is 90 times 2, that will be 180. So, solving that will be negative 25 joules. I'll correct that later. I'm sorry for that. So, let's solve for the kinetic energy of the rope. But we already have that, and we don't have the work in respect to the gravity. So, deriving the formula, that would be 80 joules minus negative 25 joules. That would be 105 joules. That is the work with the rope. And let's now solve the work that has no rope. So, again, the formula is kinetic energy is equal to work plus the work in respect with the gravity. That would be kinetic energy minus work, 80 joules, minus, since there is no rope, there will be no work happen. So that will be 80 joules. So to find how much greater will its kinetic energy, we need to subtract the 205 minus 80 is equal to 25 joules. That will be our final answer. This is our references. Thank you for listening. See you in the next lesson, though I'm not gonna teach you the other lessons. Good day. Thank you for listening.